We may think we are small compared to this Earth, but there are even smaller things to learn about, like molecules and the way they interact with each other.
This is Topic 5, Video B, and it's time to learn about balancing chemical equations. Let's take a look at the Let's Practice 2 questions. We need to write balanced chemical equations for the following 3 problems.
Whoa, that's a lot of text. Let's break it down.
If you don't remember how to convert word problems to their chemical formulas, you should brush up on your nomenclature.
You want to begin by placing the reactants and the products on their respective sides. The word decomposes lets us know that nitrogen monoxide is going to be on the reactant side, while dinitrogen monoxide and nitrogen dioxide will be on the product side. You want to begin to balance the chemical equation by writing out how much of each element you have on either side of the equation. Right now, there are 3 times as many products as reactants. We can use coefficients to equalize these values. By placing a 3 in front of nitrogen monoxide, we balance the chemical equation. Now, the number of nitrogen and oxygens on either side of the equation are equal. That was easy. Let's try a harder one.
Once again, let's break down the nomenclature. So once again, it's important to know how to take word problems and convert them into chemical equations. Note that silicon is not a diatomic molecule. So now we can take this equation and write it out in a form where we have not yet placed any coefficients. Looking at the equation, we have 1 magnesium and silicon on either side. However, we have 2 oxygens on the reactant side and 1 on the product side. We need to use coefficients in order to balance this equation. In order to have enough oxygens, we have to place a 2 in front of the oxygen on the product sides. But now we have too many magnesium, so we have to place a 2 in front of magnesium on the reactant side as well in order to properly balance the equation. In our final product, there's 2 magnesiums, 1 silicon, and 2 oxygens on either side of the equation, so we've successfully balanced it.
Once again, we want to brush up on our nomenclature. If you don't remember what the charge within the parentheses stands for, look over your notes. Once again, we have an unbalanced equation with vanadium 3 oxide and water in the product side. When we set up the unbalanced chemical equation, we see that there are 2 vanadium on both sides and 2 hydrogen on both sides. However, there are 5 oxygens on the reactant side and only 4 oxygen on the product side. To begin to balance the equation, we put a 2 in front of the H2O in order to balance the amount of oxygens. However, this gives us too many hydrogen on the product side. In order to balance the hydrogens, we then put a 2 in front of the hydrogen gas on the reactant side. Now that we've balanced the equation fully, we find that there are 2 vanadium on both the product and reactant side, as well as 5 oxygen and 4 hydrogen. Balancing chemical equations is an important part of chemistry, and chemistry helps us understand even the smallest parts of our world.